Hello ladies and gentlemen, welcome to the Day 12 video, which covers section 5.4, complex numbers. We're going to be spending 2 days on this section. We have 3 objectives for today. First, we're going to simplify imaginary numbers. So we're going to talk about what imaginary numbers are and we're going to simplify them. And that's part of complex numbers. And then we're going to perform operations with those imaginary numbers and then also with complex numbers as well. So the first thing is a review. I would like you to take a minute and graph y equals x squared, add 2x, add 4 in your calculator. And then I want to know how many real roots or solutions does the quadratic have. So pause the video, graph the equation, and just tell me how many roots are there. Not what they are, just how many are there. Okay, so let's see how we did. When you graphed, you should have gotten something like this graph here. So how many real roots? Well, the roots are where the parabola crosses the x-axis. Our parabola does not cross the x-axis. So our parabola, or our quadratic, has 0 real roots. Okay, but I have a power of x squared. That means I should have 2 roots. Okay, if there's no real roots, there's going to be what's called 2 imaginary roots. And that's what we're going to be learning about today. So imaginary numbers use the imaginary unit I. This is defined as I squared equals -1. Therefore, I equals, well, if I take the square root of I squared and the square root of -1, I is the square root of -1. Okay, so this is called imaginary. In the past, every time we got a square root of a negative number, we just said no real solution and we didn't continue. Okay, these numbers do exist, but they're called imaginary numbers. So anytime you have a negative under the square root, it's imaginary. So looking at example 1, this is the first thing that we have to do, is simplify imaginary numbers. Okay, so let's start by simplifying the square root of -45. I'm going to show you 2 ways to do it. The first one is to break this down into prime factors. So first thing I want to do is -45 is -1 and then 45. Okay, so that square root of -1, that's I. Sorry, that should be an I. And then 45 is 9 and 5. 9 is 3 and 3. Here's a pair. So one of the pair comes outside. The 5 stays under the root because it doesn't have a partner. And then I also have that I. So it's 3i root 5. Another way to do it is just to look for the perfect squares. So I still have that square root of -1, which is just I. And then I have 9 and 5. The square root of 9 is 3. Root 5 stays there, and then the I also comes out. So either way, I personally use the first method where I look for the pairs, but you can also use the second method where you look for perfect squares. So that was the first example. Right now, pause the video and try the second one on your own, please. Okay, let's see how we did. So -20, that's -1 and +20. -1 is just I. 20 is 4 multiplied by 5. 4 is 2 and 2. So the 2i comes out. And then the root 5 stays under, or the 5 stays under the root. If you looked for perfect squares, you would have gotten 4 and 5, which is still 2i root 5. So hopefully that one went well. We're going to do one more example just to practice. Okay. So let's do this last example. Pause the video and try this one on your own, please. Okay, so first thing that I would do is multiply these two. 6 multiplied by 15 is 90. So this is the square root of -90, which is -1 and then 90. Square root of -1 is I. 90 is 9 and 10. 9 is 3 and 3. 10 is 5 and 2. So the 3's are the pair. The 5 and the 2, they don't have a partner. So the 3i comes outside, and then the 5 and the 2 stay under the root, which is 10. So 3i root 10 is what you should have gotten. And you should be doing this without a calculator. I forgot to tell you that. So hopefully that one went well. If you have any issues with the previous two examples, please make sure you bring them to class. Okay, a few properties. I is equal to the square root of -1. We already talked about that. If I square that, I get -1. So I squared equals -1. So that's going to help us. If you would flip the page, please. Okay, so now we're going to simplify, continue simplifying imaginary numbers. So I to the 44th power. There's a few different ways to do this, but what I do is I always break this down in terms of I squared. So how many times does I squared go into 44? Well, how many times does 2 go into 44? You should know that it goes in 22 times. Okay, so if I multiply 2 and 22, I get 44. Okay. Now I squared is just -1, so this is really -1 to the 22nd power. Well, a negative to an even power is always going to be positive. So this is really just +1. Okay, so let's look at the next example. This is I to the 63rd. So I still break it down in terms of I squared. Well, this time 2 does not go into 63 evenly, but it does go into 62. Into 62 it goes 31 times. But then I have an I left over, since it's I to the 63rd. Okay, pause the video and see if you can finish this, please. Okay, so I squared is -1. So this is really -1 to the 31st power multiplied by I. A negative to an odd power is going to still be a negative. So this is -1 multiplied by I, which is just -I. So hopefully that one went well for you. If not, we're going to get a little more practice with the next example. Okay, we're going to continue to perform operations. I'm going to do the example on the left. You're going to do the one on the right. So -5 multiplied by 3 is -15. I multiplied by I is I squared. But I know that I squared is just -1. So this is -15 multiplied by -1, which is +15. Okay, right now, pause the video and try the next one on your own, please. Okay, so we should have had 12i to the 4th. Okay, now I to the 4th is I squared squared. So this is really 12 multiplied by -1 squared. -1 squared, though, is just +1. So it's 12 multiplied by +1, which is just 12. So hopefully that one went okay. Okay, so up until this point, we've only done imaginary numbers, so the numbers that have I. Now we're going to introduce complex numbers. So complex numbers are written as A plus BI. The A is called the real component. The BI is the imaginary component. Okay, so now we're going to do some operations with complex numbers. So with complex numbers, we can perform the same operations as with just integers. So we can add, subtract, multiply, divide. So today we're going to focus on adding, subtracting, multiplying. And then dividing we'll do in tomorrow's video. So let's look at example 4. Perform the following operations. So we see that I'm adding two complex numbers. I'm allowed to add the real parts. So 5 add 2 is 7. And then I'm allowed to add the imaginary parts. -7i and +4i is -3i. Now, these are not like terms. This is like 7 subtract 3x. 7 and 3x are not like terms. 7 and -3i are not like terms. So we just leave our answer like that. That's it. Right now, pause the video and try the second one on your own, please. Notice that in the second example, we are subtracting, so please make sure to distribute that negative. Okay, let's see how we did. We have 4 subtract 3, which is 1. And then we have negative 8i subtract negative 6i. So really that's negative 8i add 6i, which is negative 2i. So you should have had 1 subtract 2i. If you can't do that in your head, you should have distributed the negative. So it became negative 3 add 6i. So this is our final answer though, 1 subtract 2i. Again, if you have any questions, please make sure you bring them to class. We have 2 more examples and then we are finished. So example 5 is with multiplying complex numbers. So the first example, I'm multiplying 2 complex numbers. So some of you like to do the arcs, which you are welcome to do. I personally do the box. So I have 5 subtract 7i and 2 add 4i. 5 multiplied by 2 is 10. 2 and negative 7i is negative 14i. Then we have 20i and negative 28i squared. Okay, so this becomes 10. Negative 14i and positive 20i is positive 6i. And then I'm subtracting 28i squared. Okay, I'm not finished yet. I'm not allowed to leave this I squared. So 10 add 6i minus 28. I squared is negative 1. So this is really 10 add 6i, and negative 28 and negative 1 becomes positive 28. So really this simplifies to be 38 add 6i. Okay, this last example you have to do. I am going to give you a hint. You are not allowed to distribute that squared. So the first thing that you should do is rewrite this. This is 1 add 2i multiplied by 1 add 2i. I would do this in a box, but some of you like to just draw the arcs in, which is fine. When it's all said and done, your answer should be negative 3 add 4i. When you come to class tomorrow, we will be checking to see that you have this problem completed with all of the work. Good luck.